next test, we have a Bino Power 24 volt 20 amp hour battery, lithium iron phosphate, in conjunction with their power controller. A little bit more pricey, but I like it because it's ROHS compliant and they have excellent customer service. We're going to test this 24 volt Amarine made pump. The Turtles already have a 12 volt, so we thought we might try the 24 volt out. Here's our schematic of the circuit. Notice that we do not have the pump hooked up to the load output. Instead, we have it connected directly to the battery through the distribution block. This is because many of the controllers can't handle that first inrush of current as the capacitors charge. There is a device that may be able to fix that issue for like $5, an NTC inrush current limiter. But for this experiment, I've simply hooked up the pump to the battery. I'm using these Anderson power pole connectors. I've got the battery output connected to this distribution block right here. And then I've got the output from the controller to the battery hooked up in parallel here, but this allows me to connect other devices to the battery directly. This distribution bus turned out to be a lifesaver because I was trying to test the voltage on the current setting that will create a short circuit, but I just blew this fuse right here, so I didn't do any damage to anything. So I'm going to run it off this 10 amp circuit on the distribution block, which is connected directly to the battery. Pump is working. It's actually raining, super hazy, not very bright at all. I have the solar panel in a horizontal position to try to get all this ambient light. I paid 90 bucks for this used panel, but you might expect to pay $1 a watt or 180 for something like this on Amazon. Sending about 0.19 amperes to the battery. I'm just going to run this pump without any load. I don't have the right fitting for the output. Right now, under no load, this 24 volt pump is drawing 2.2 amps. Under load, our battery voltage is about at 26.6 at the beginning of this experiment. According to this meter, it's at 26.7. It is now 1 p.m., but I'm just going to let this run to see how long this battery can hold up. 1 hour later, the pump is still running. It's still raining, although it's let up a little bit. I slanted the panel just so we'd get a better drainage. Right now, our battery is at 26.8 volts. We've sent about an amp hour to the battery from the panels, even in this low light condition. The panels are still putting out 34.5 or 35 volts. And we're charging at 1.7 amps right now. According to this, the state of charge of the battery is still 100%. But with these lithium iron phosphate batteries, they stay basically at the same voltage until they're almost dead. So that may not be accurate. It's now 2 hours later, still running. Let's see, 26.8 volts still. Yeah, we've sent 3 amp hours through this thing to the battery. Still providing 1.3 amps, even this really rainy conditions. You can see the panel's all wet. We are getting some kind of hazy light though, and apparently it's enough to provide 1.3 amps. 3 hours later, still raining. Still pumping. We're still even charging at 0.42 amps. That a good portion of that's probably going to the pump though. At 26.6 volts. We've sent 4 amp hours of energy to the battery. Sun has already gone down. It's now 10 to 9. It's been almost an 8-hour test. You can see the pump is still going. Cycle through. The battery now is at 95%, so we have drawn off 5% of the battery in the 8-hour test. The battery still is now at 26.3 volts. 8 amp hours was sent from the panels to the battery. Must have used quite a bit of that with our pump. Nothing sent to the load because we don't have this load. Many of the controllers, you can't really hook up any high current load to the controller. It's more for lights and phones and stuff like that. The panels are still at 29.1 volts or 28 volts, but there's no current there hardly at all. This Bino Power battery has got its own electronic protection, so I'm just going to let it run all night. It'll shut itself off when it gets too low. So you don't have to watch this for another 7 hours. Here's a summary of basically what happened for the entire test. We started our test off with 20 amp hours of energy in our 24 volt battery. That did deplete over the course of the experiment, although our panels were providing some of the energy for our pump. Our pump demanded about 2 amps the entire time, so approximately 30 amp hours of energy were consumed by the pump. We were able to maintain pumping for a total of about 15 hours with this 20 amp hour battery. If we had a more sunny day, we could probably go longer. It should be noted that we do have an additional solar panel. However, it is likely that the actual load will be twice as much as we had, probably closer to 5 amps, assuming we have to actually pump some water uphill. I wanted to include some full sun footage just so you can see what this thing can do. In full sun, I was getting 5.81 amperes, which is enough to not only power the pump, but to also charge the battery simultaneously. So in full sun, we can do a lot better. So the main takeaways from this experiment were, first, you're going to need more than a 500 watt hour battery if you want to pump all day and all night. For example, the Mighty Max 12 volt 100 amp hour could work for this application. Keep in mind though that lead acid batteries, if you deplete them over 50%, you could shorten the life of the battery, or you definitely will. Number two, this system could pump over 1,000 gallons per day if nothing went wrong. Key caveat there. Three, important to individually fuse your panels, fuse your load, and fuse your battery to make the system more hippie-proof. Of course, it's impossible to make it completely hippie-proof. I found that my fused distribution block was good for that. It also allowed me to access the battery for additional connections. And finally, I found that when I was moving the panels around, I could double my power production just by manually adjusting the angle of the panels. So one idea would be hippies hanging out at a water camp or something like that who could act as trackers, so to speak, to keep the panels directed towards the sun. That's all for this test. Turtles love you.